Vectors, page 16. The scalar product of two vectors, okay, which is written with a big dot in between the two. It's read v dot w. It's also called the dot product or inner product, depending on which course or which book you're looking at. If you have two vectors expressed in component form like that, then the scalar product of vector v and vector w is v1w1 plus v2w2 plus v3w3. This next part, I'm just going to present some of the properties of dot products or scalar products and things that came out of the derivation that we looked at in the investigation. But the cosine theta of the angle between the two vectors that you're multiplying together with the dot product can be found by taking the dot product of the two and dividing by the magnitudes of each vector. And the dot product of v dot w is also the same as w dot v. V dot v is gives you the magnitude squared. V dot w plus x, you can kind of do a distributive property on it. It's equal to that. And v plus w dot x plus w will give you v dot x plus v dot y plus w dot x plus w dot y. Geometric properties of the scalar product. For non-zero vectors v and w, v dot w equals 0 is equivalent to that v is perpendicular to w. Okay? And v dot w is equal to the magnitude of v times the magnitude of w. That's equivalent to v is parallel to w. Okay? Let's see, if theta is the angle between the vectors v and w, then v dot w is equal to magnitude of v times magnitude of w times cosine of theta. If theta is acute, then cosine theta is greater than 0, and so v dot w is greater than 0. If theta is obtuse, cosine theta is less than 0, so v dot w is less than 0. So first we're going to do the dot product of -1, 5 and 3, 2. And the way we do it is we just take the x coordinates here, -1, 3, multiply them together, we get -3. We take the y's, 5 and 2, we multiply them together, we get 10. And then we're just going to add those two together. So -3 plus 10 gives us 7. Okay, and so the dot product is actually a number. It's not a vector. So then we're going to do 2p dot with 2, or 2q dotted with 2p. So 2 times the p vector dotted with 2 times the q vector is going to give us 6, 4, and 6, 4. And so we multiply the two 6's together, we get 36. We multiply the two 4's together, we get 16. And then we add them together and we get 52. That's the dot product of 2p dotted with 2p. Now C, we're going to take the q vector and dot it with p plus r. P plus r is just this plus this, so it would be equivalent to 1, 6. So we're going to dot -1, 5 with 1, 6. So we multiply -1 times 1, we get -1. We multiply 5 times 6, we get 30. And we add those two together, we get 29. Q dotted with j. We're going to take -1, 5, and we're going to dot it with 0, 1. Because j is the j vector is the unit vector in the j direction. So that's -1 times 0 would be 0, and 5 times 1 would be 5. And add those two together and we get 5. And that's it.